Mostly your exams are easy. Just you have to focus on the formulas that is given to you at the end of your exam. In this exam there is no formula, but you have the formulas at the end of the exam. So be used to that formulas. It will be very helpful in getting things done. So I advise you to use the formula sheet for the exam. So this exam we will start uh, from question number 16. So because your exam contain from the chapter 5 to 10, so we're going to solve only those problems that is related to chapter 5 and 10. So the most important formulas in chapter 5 to 10 are these. So which we going to frequently use. Okay, so the first formula is sum of all forces, which is Newton's second law, is mass time the acceleration. This is the heart of this course, Newton's second law. Then in chapter 6, we have learned that the work energy principle, that the work is stored is the change in energy, change in kinetic energy. So kinetic energy is K2 minus K1, which is nothing but 1 half mvf squared minus 1 half mv squared. And the work is defined as F dot D or F D cosine of theta. So this is the most important formula as well. 1 and 2. Then we have learned the conservation of energy. If there is no external force or no other work, then you have change in energy is equals to 0, which means that E2 minus E1 equals to 0, which is E2 equals to E1. So what is E1 and E2? This is the total energy. What is the total energy? Sum of potential energy plus sum of kinetic energy. So what is potential energy? Which is mgh, which is for the energy related to the position, and energy related to the motion is this. If you have another force that is acting on it, then this rate of the change in energy is not zero. Otherwise, it is equals to the work done by other forces like the frictional forces or the force that you applying on any system. So this is the conservation of energy. And if the body is not in under the conservation of energy, then we have to apply this formula. Then the energy stored in elastic potential energy or the spring is 1 half kx squared. Then we learn momentum, which is nothing but the mass time the velocity, and momentum is related to the force by the change in momentum divided by time, or you can write like dp dt. And this is the another form of the Newton's second law. And this is related to the quantity impulse, which is nothing but the change in momentum. So change in momentum is mvf minus mvi. And then we learn the moment of inertia, I is mr squared, tau is r cross f, and angular momentum, which is r cross p, which means rp sine theta. So whenever you have a cross product, you have sine theta, and whenever you have a dot product, you have a cos theta. And then the last thing is the law of conservation of angular momentum, which says that I omega is constant, no external torque acting on it. And another important law is the law of conservation of momentum, which is delta P equals to 0, which means P1 equals to P2, momentum before collision and momentum after collision. So you can write like this: m1 v1 plus m2 v2 equals to m1 v1 prime plus m2 v2 prime. So this is, so these are the most important formula, but but you have, sorry, but you have a lots of range of formula. Every formula was given to you, so we're going to use these formula and you will get to know. Okay, so let's start from the first question. So the first question is this. So the first question is this, that question number 16, which starts from chapter number 5. A force is acting on the object with a mass m sitting at rest. It means it is in equilibrium and the frictionless incline is shown here. The magnitude of the force. So magnitude of the force. So if you see the force, then it is related to its, like its weight, and this angle. So now, then you have two components of this force. One is uh, the x component and one is the y component. So like this. So you have force component, which is F, F sine theta, and F cosine theta. And your F is nothing but your weight, which is mg. So the force will be, because it's along the y, so mg sine theta. And when you substitute the value, sine 20 degree, then you will get to know that this is 50.3. Okay. Next question, question number 17. So a block N, 300 Newton. So this is 300 Newton, which is the weight of the object or the normal force, because weight is related to the normal force, is pulled by 100 Newton force. So this is pulled by the 100 Newton force at an angle 30 degree, as shown in the figure aside. So this is the weight of the object W, or the normal force, and then normal force is opposite to the weight of the W. So this is the angle theta you have, and this. What is the acceleration of the object? So Newton's second law says that the sum of the object, the sum of the force is equals to the mass times the acceleration. So if the kinetic coefficient of the friction, so friction, you are applying a force in this direction, so it has two components as well. This component is F cosine theta, and this is F sine theta. So the motion is along this direction. So we will going to consider the component, which is this cos theta. Okay, and friction is a force that is always act opposite to the motion, always act opposite to the motion. So the frictional forces is nothing but the mu k, or mu fk, is normal force. Okay, and it is always opposite to the direction of the motion. So now the sum of all forces, we have the weight of the object, and the force is mg cosine of theta, okay, minus the kinetic friction force, which is opposite to the force. This is the sum of the force, which is equals to the mass times the acceleration. So your acceleration is mg cos theta minus mu kn divided by m. So when you substitute the value into it, you will get the acceleration, which is 2 meter per second. Next question. So next question, if M is supported by the ropes as shown in the figure, the tension T, this is T1, this is T2, and this angle and this angle according to geometry is 30-degree. So this component is T2 sine theta, and this component is T2 cos theta. So if you see this, the tension, this T1, is along the direction of the x component of T2. So your tension in T1 is related to T2 by this factor, which is T2 cosine 30-degree. So your option A is correct in that case. Okay, so
Doctor,
yeah,
what about the weight?
weight
Yeah, on the
weight
tension.
weight is downward.
Yes.
W is equals to mg, and this is the normal force.
No, it's not connected for the T2.
But doctor, yeah, doctor, so the weight won't shouldn't it also be included?
Yeah, but we are talking about now the tension in the string. So tension is related to the weight as well. This tension is nothing but T is equals to mg. Okay,
Okay.
because when we sum of all the forces, then we add the vectorial. If we draw the free body diagram, then we will do. But now we just need a tension which is related to the tension T2. Okay, now moving to the next question, which is question number 19. A 615 Newton woman standing on the scale of the elevator, that the scale reads 45 645. From the information, the woman knows that the elevator is not accelerating. That's not correct. The must be moving with a downward acceleration, must be moving with an upward acceleration, or it's not moving. If it's not moving, then the weight will be the same. So this is not the option. Now we left with two options. So in both of these cases, we have to add the acceleration to the motion. If the weight got increased, then the motion is upward, and if the weight got decreased, then the motion is downward. So in that case, if you see from 615 Newton to 645 Newton, the weight of the object or the woman inside the elevator is increased. So it is going upward. If it got decreased, then it's going always downward. Question number 20. So a 100-kilogram car, yeah,
Wait, doctor, can you go back up? So like, how will we know if if it should go upwards or downwards?
because when we, for example, if the object is in this direction, acceleration in this direction, and the gravitational force is in this direction, so the sum of the all the forces will be the gravitational forces mg plus the ma. So m is the common, so g plus a. So it means you are adding the acceleration. So if it goes upward, or like is equals to the mass time acceleration. So is equals to the mass time acceleration. It means so mass time acceleration. So ma. Okay. So this is equals to then the sum of all forces. No. So sum of all forces equals to mass time acceleration. So if you see this, the weight of the object is downward, okay, and the acceleration is downward. So now these two forces added, it means you are adding weight to the acceleration. Or, okay, then if it is going upward, then it me it means you are subtracting in that case if it's going downward, and in going upward you are increasing the acceleration, because when it goes from here to here it become uh, negative to positive because they are in opposite direction. So in that case the weight of the object is increased due to this acceleration, which is in the upward direction. So when you go on elevator up, you feel sometime dizzy, which is the apparent increase in your weight. Okay. Okay. Now moving to the next question, which is rather easy. A 100-kilogram card is traveling at a constant speed v, enters a horizontal circular road of 40-meter radius. So this is your mass, this is your radius, and this is the net force acting on it. So what is the speed of the car traveling on a horizontal circular road? So now the concept of circular motion came, and the force related to the circular motion is the centripetal force, which is mv square over r. Now, what is asking you to calculate the speed? So speed is fc r over m. Then taking the square root, so v will be fc r over m. So you have fc, you have m, you have r. Just substituting the value will give you the answer 10 meter per second. Okay. Question number 21. A 2-kilogram object is pushed along the horizontal surface by 10 Newton force acting 20 degree. So acting 20-degree angle below the horizontal. How much work is done by this force? The object moved 5 meter. So work done is what? F d cosine theta. So you have force, you have angle, and you have a distance d. So d, f, and theta. So just substitute the value and you will get 47 of joule. Question number 22. So what is the kinetic energy of 1 kilogram mass moving at the velocity? So kinetic energy very easy, which is 1 half mv squared. So m is 1, so 1 half 40 squared, and you will get
800.
800 joule. Great. Okay. Now, a box of 4 kilogram mass initially moving with the speed, initial speed Vi or V1 as you wish along a rough horizontal surface floor. It stopped after it moved to 5 meter. Find the work done by the friction. So work done by the friction, we're going to apply work energy theorem. Okay. So if it stopped after some time, which means its final velocity is zero. Its initial velocity is zero. So the work energy theorem says that the work done is equals to the change in kinetic energy. So change in kinetic energy is K2 minus K1 or Kf minus Ki, which is nothing but 1 half mvf squared minus 1 half mvi squared. So this is 0 because it stopped. Then the work done is negative 1 half mvi squared. And this work done is due to the friction because, and you see that it is a negative sign. So it is always opposing the motion of the object because the work done is nothing but the force time displacement. So when we substitute the value, because we have Vi, we have the distance, and we have this, so the work done is negative 50 joule. Question number 24, rather easy. So which of the following is the unit of the power? So power is defined as rate of doing work. Whenever you have a rate divided by time. So work is nothing but force time displacement time time. So either you write as Newton meter divided by the second. So this Newton meter is equals to joule divided by second, or this has a name watt. So all these are the unit of the power. So see the option, which unit is matching? I think joules per second. Yeah. Okay. Now, question number 25. A 2 kilogram ball is thrown upward like this. It reaches to the maximum height above the Earth's surface. Above the Earth's surface. This is the Earth's surface, if you say. What is the potential energy at the maximum height? So potential energy is rather very easy question, which is mgh. Just substitute the value. M is 220 and height is 20 and G is 9.81. You will get 392 joules of energy. Now, we just calculated, if you see this, the SI unit of the potential energy. So potential energy have the formula. Potential energy is nothing but mgh. So m is kilogram. G is the acceleration, and acceleration has a unit meter per second squared. And height is also meter. So your unit will be kilogram meter squared divided by second squared. Or this is equivalent to joule, and joule is equivalent to Newton meter. Okay. So these are all the units of joules or energy or work done have the same unit. Kinetic energy, potential energy, elastic potential energy, work done, all have the same unit, which is kilogram meter squared per second, joules or Newton meter. So which unit is this? I think so. C. Yeah. Now question number 27. A skier starts from the rest, and this is the information. Start from rest, which means its initial velocity is zero. a sliding down at a slope theta. Here he reaches the speed at point B. This is the point B, which is Vf, ignoring the friction. There is no friction. What is the height h? So there is no external work, okay, that has been done. So your law of conservation of the energy holds. What is law of conservation of energy? This is delta E equals to 0, which means that E2 minus E1 equals to 0. So energy before and energy after is equal. So what is total energy? Total energy is sum of the kinetic energy and the potential energy. So kinetic energy is 1 half mvi squared, sorry, m2 over here, or vf, or in that case 2 is the final position. Then mgh2 equals to 1 half mvi squared plus 1 mgh1. So it starts from here. This is your h1. It ends over here. This is your h2. So h2 is 0. Initial velocity is 0. So what you left with? 1 half mvf square equals to mgh. So h and h will be cancelled out. M and M will be cancelled out. So your H is Vf squared divided by 2G. So Vf is this. G, you know that 9.81. And when we substitute the value, we will get 160 meter of height. Yeah. Question number 28. So the 2 kilogram object is the 2 kilogram object in the figure shown is moving with the velocity 7 meter per second on a smooth surface except point B and C. So here this point B and C, which is having the friction in that case. And then the coefficient of the friction is zero point 0.1, which is mu. So when the object is stopped by the spring, what is the maximum distance the spring is compressed? So what is the maximum distance the spring is compressed in that case? So if you know work energy principle, now your work is the external work is done. Okay. So work net is equals to the change in kinetic energy. So the object is 2 kilogram object is moving with the initial velocity. So this is in VI, and if it stop, its VF goes to 0. Okay. And when we substitute the value, so and this is the elastic potential energy. So it's stored, the work done stored, the energy stored in terms of the work done. So now the energy stored is 1 half k x squared, and the work done during this is the work done due to the friction, and the work done due to the friction is the friction force time the distance x1, we say that, which is 6 1, and then the kinetic energy, change in kinetic energy, because change in kinetic energy is, so the kinetic energy, we're going to take only this. So now we wanted to find this x from here, and we took all the constants on the other side. So 1 half kx squared equals to 1 half mv squared plus fs, which is mu n x1. So your x will be 1 half mv squared plus mu n x1 times 2 divided by k square root. And when we all substitute all the values, because we have everything in that case, because m, v, mu, this is mu, and n is the weight of the object, 2 multiplied by 9.8, and then x1, this is this distance, and k is this constant. When we substitute the value, we will get 39 centimeter. Question number 29. So a 10 kilogram crate is moving at 6 meter per second. So 10 kilogram crate is moving with 6 meter. Linear momentum, very easy. Momentum is mass time velocity. So 10 multiplied by 6 is 60 kilogram meter per second. Very easy. Question number 30. So 80
Doctor,
kilo. Yeah,
can you repeat the question number 28, please?
okay. So question number 28 is like this. So an object is moving with initial velocity, and then it has moved to a rough surface, and then it hits to a spring, and the spring is compressed. So we wanted to know at what at what distance this spring is compressed. Okay, so because the object is moving, it has kinetic energy, and it's moving to a rough page and then connecting to a spring, then we need to apply the work energy theorem, which says that this. So for the whole situation, the energy stored in the spring is the elastic potential energy, which is the work done by this object on this spring, which is this. This is the work done stored due to friction. It is always negative. And then the change in kinetic energy is just the 1 half mv squared. So we wanted to know what is this x? What is this x? So we just calculated that x, which is 39 centimeter. Okay.
Yes, clear.
Okay. Now, question number 30. An 80 kilogram person is running at an initial speed, jumps onto a 120 kilogram cart initially at rest. What is the final velocity of the cart? So when it jump on the cart, then they move with the some velocity. Okay. So now, to tackle these kind of situations, we need to apply the law of conservation of momentum. So what is law of conservation of momentum? Is the change in momentum equals to zero, which is nothing but P1 equals to P2. And so what is momentum before collision? Because we have two bodies, M1 V1 plus M2 V2 equals to M1 V1 prime plus M2 V2 prime. So this is the condition. Now, this is we have M1, this is we have V1, this is we have M2, and it is at rest, which means V2 is 0. And then the person got jump onto the cart, and they have moving with single velocity. So now in that case, V1 prime equals to V2 prime equals to V. So our equation M2 goes to 0. So we have M1 V1 equals to M1 plus M2 because they are moving with the same velocity. So now we're going to calculate this V, which is nothing but m1v1 divided by m1 plus m2. Okay. Or you can have a situation like this: the object is moving in this direction, and after that, they stick together. So this is a similar condition like this. So we need to put just the substitution of the values, and we will get our V, which is 1.6 meter per second. Question number 31. Which is true for an inelastic collision? So there are two types of collision: elastic and inelastic. So in elastic, kinetic energy, total energy, and momentum of the system conserved. In inelastic collision, kinetic energy is not conserved, total energy is conserved, and the total momentum is also conserved. Okay, so which option is this in which the kinetic energy is not conserved? So both momentum and kinetic energy is conserved. No, momentum is conserved, but the kinetic energy is not conserved. That is the option. Momentum is not conserved. That is not the option. Both momentum and no. So this is the option. Question number 32. So the particle moves along the x-axis. Its momentum is a function of a time as shown by the this plot. The slope of the curve. So slope is just 2 points. So how to calculate slope is just y2 over I1. So this is your, if we select these 2 points. So this is P1, this is P2, and the corresponding T1, T2. So slope, you find it out, P2 minus P1 divided by T2 minus T1, which is nothing but delta P over delta T, and rate of change of momentum is equals to the applied force, which is Newton's second law. And so the rate of change of momentum, the slope of the curve, is give you the force. Question number 33. The cylinder is rotating counterclockwise. Counterclockwise. So apply your right hand rule. Thumb will indicate the direction of the angular velocity. So if you curl your finger anti-clockwise, your thumb indicating the the direction of the angular velocity. So what will be the direction? If you apply your right hand rule, the motion is like this, and the direction of the velocity is upward. Thumb will indicate the direction. So your curl finger will move in like this, curl finger in the direction of the motion, and the direction of the angular velocity is indicated by thumb. Very easy. Question number 34. A 0.6 meter radius, so this is R, flywheel rotates at a constant acceleration. This is alpha because it's radian per second. It starts from rest, which means its initial velocity is 0. How many revolutions does it rotates in 5 seconds? So it means its initial velocity is 0. So how many revolutions, which means we need to find the theta. So theta is omega I t plus 1 half alpha t square. So omega I is 0. So this term is 0. So we left with 1 half alpha t squared. So 1 half alpha is 2 and t is 5. So you will get 25 radians. So when you have measuring in a circular motion, the angle is in the radian. So this is 25 radians, but this is not revolutions. Each revolution contain 2 pi. So this revolutions has to be divided by 2 pi. This radian theta is divided by 2 pi. So when you divide it by 2 pi, you will get the number of revolutions. Okay. So these revolutions are, you will get 3.976 approximately, which is equals to 4 revolutions. Question number 35. Consider the system as shown. The mass of the connecting rod is negligible. The mass of the connecting rod is negligible. What is the moment of inertia about the y-axis? What is the moment of inertia about the y-axis? So the object is rotating like this. This is the center of the motion. So moment of inertia is nothing but m I m r square. So along this, there is no r. So for this mass, the moment of inertia is 0. Only we have to calculate the moment of inertia of this. And this is the r. So m is 1.5, L is 2 squared. So when we calculate this value, you will get, I think, C. 4 multiplied by 1.5 is 6. Okay. Now, the next question is very, very important and very conceptually rich. So be focused on that. So a frictionless pulley is this radius of moment of inertia I. At this mass, stone is attached to a light wire and it is wrapped around on the rim. So the this stone is wrapped like in the string on the rim. So if the pulley system is released from rest, which means its initial velocity is 0, we only consider the final velocity, then how far must the stone fall so the speed reaches to 2.5, 2.7 meter per second. So this is the final velocity. So now the concept of rotational energy and the concept of linear energy is coming out. Okay. And because of this height, you have the potential energy as well. Okay. So when this object is in this position, so all the energy stored in this rotational energy, when it moves, some of the rotational energy convert to the kinetic energy, and then the kinetic energy is converted into the height, which is the potential energy, and then it will stop, and all the energy will be stored in the potential energy. Okay, so mgh, which is the potential energy, then you have the energy, which is kinetic energy, due to final, because it starts from rest, initial energy is 0, and it has some rotational kinetic energy, which is nothing but I omega squared. So here we need to find h, which is 1 half mvf squared plus 1 half I omega squared divided by mg. So just putting the values, because we have m, we have I, we have omega, so we don't have omega. So we need to find omega. So omega is equals to rv, or v is equals to r omega. So V is equals to R omega. So omega is V over R. So it has only the final velocity. So this will be the final velocity. So we will get omega from here, Vf over R. R is this. So then we substitute the value over here. The mass of the stone is there and all the constants are there. Now, if we find out this, sorry, you will get 0.68 height of this. Question number 37. The three cases A, B, C, D below the force Fx on a cylinder, in which case the force exert the biggest magnitude of the torque. So if you see the torque, it's R cross F, which is nothing but RF sine theta. So in which condition? So if it is this, in which condition sine theta? So sine theta maximum will be on the angle 90 degree. So this is the moment arm, this is the moment arm, this is R, this is F. So this is moment arm, this is R and this is F, and this is the moment arm and this is R and this is F. So in the three cases, the angle 90 is getting in the only in the first thing. In that case, they both are or NT, or if it's in those, they are zero. And if they are in this direction, then they are equals to the angle is different. So only the case A is satisfied. So the maximum torque we get is R cross F, which is at angle of 90 degree. So only in the case A is correct. Question number 38. So a rod of length L
Doctor,
is, yeah,
can you please repeat number 37 again?
37.
Yes.
Okay, so the definition of the torque is R cross F. Whenever you remove the cross product, you will have a sine theta. Okay, so sine theta will be maximum at the angle 90 degree. So you need to find an angle between the R and F. If the angle is 90 degree, you will get the biggest or the maximum torque. So in that case, the angle is not 90. So in that case, the angle is not 90. But in that case, if you see this is a force and this is the direction of the torque, or this is the direction of the moment arm. So the both angle is in between them is 90 degree. So the maximum torque only get for the angle 90 degree. A rod, next question.
Okay, thank you, doctor.
Okay, so a rod of length 2 meter can rotate about, about the origin. Find the magnitude and direction of the torque. Next is the question of the torque as well. So torque is R cross F. And then you have RF sine of theta. Now the origin is this, and this is your moment arm, and this is the force, and this is the angle. So this is R. So the whole length is 2 meter, but the R, which is from here to here, is equals to 1 meter. Okay. So so rotate about the origin. Now, so this is our F sine theta, and we have the unit vector. So sine theta is 30 degree. Force you have 10 and R is 1. So when you calculate this value, you will get, and you will find the direction by using the right hand rule. So right hand rule, put your fingers in the direction of the R, okay, and then thumb will indicate the direction of the torque. So in that case, the direction is, because the force is in this direction, so it will move in this direction. So is it is into the page or out of the page?
Into.
Into the page. Good. So 5 Newton into the page. Question number 39. Which of the following is the SI unit of angular momentum? So you will have the formula of angular momentum, which is L is equals to R cross P. And when you remove cross product, you will get sine theta. And the maximum sine theta will be on 90-degree. So we suppose that they are maximum. So your momentum is RP, angular momentum. And R and momentum is mv, linear momentum. So now we pull the unit. So R is measured in meter, m is measured in kilogram, and v is measured in meter per second. So your unit will become kilogram meter squared over per second. So I think the option D is correct. The last question and the important question as well. Okay. So a wheel with the moment of inertia is given by I1, mounted on a vertical shaft with negligible moment of inertia, is rotating with the speed 10 meter radian per second. So another wheel with rotational inertia is this, is rotating with the speed this. So this is your omega 1, this is your omega 2, suddenly drop into the shaft. So if you remember one problem like this, so they become 1. This is linear momentum. And now this is angular momentum. So this is before and this will become after. Okay. So the resultant combination of the two wheels will rotate at what speed? So now we wanted to find the total speed or angular speed of these two objects. So now we're going to apply the law of conservation of angular momentum, which says that the change in angular momentum is equals to 0, or the momentum before and the momentum after are equal. So what is momentum before? These two. And what is angular momentum is nothing but I omega. So I omega is I1 omega 1 plus I2 omega 2 is equals to the momentum after. So they combine and then rotate, then their moment of inertia 1 plus moment of inertia 2, and they move with a constant angular velocity. So now we will find I1 omega 1 plus I2 omega 2 over I1 plus I2. So we have I1, I2, omega 1 and omega 2. Just we need to substitute the value. We will get 5.7 radian per second. Okay, so this was the exam.
Wait, doctor, can you go back to the last? Can you re-explain the last question again?
Okay, sure. So if you start the question, a wheel with the moment of inertia, this is a wheel, or this is the wheel, V1, moment of inertia, mounted on a vertical shaft, and with negligible moment of inertia, is rotating with the speed. So one is rotating with this speed. This is omega 1 because it's angular velocity. Another wheel is rotational inertia, which is rot- moment of inertia this, and is rotating with this velocity. So if you see this, they have the same direction. And then this wheel is dropped onto that shaft, and then they combine and move with the constant angular speed with the combined velocity, angular velocity. So now in that case, we need to apply the conservation of the angular momentum. So because they are colliding, so the momentum before and the momentum after, angular momentum I'm talking about, so angular momentum equal. So how to define an angular momentum? Angular momentum is nothing but angular momentum is L is equals to I omega. So angular momentum before and angular momentum after should be equal. So what is angular momentum before? Is first body, which is I omega first body. So I1 omega 1, second body I2 omega 2. This is before momentum. And after collision, so they combine these two into one. So their masses, in that the previous case, mass is added. Now in the cases of the rotational motion, their moment of inertia added, and they move with a constant velocity. So we need to find out that particular velocity, which is angular velocity, about which they are moving after when you put this on the shaft. So we calculated this, and this we will get 5.7. So this is the one exam I have solved for you.
Doctor,
Yeah.
you start from question 16. Why?